The peak of the curve corresponds to maximum power P naught at resonant angular frequency omega naught. Li is further clear that P becomes less at low and high frequencies. 2. Half maximum power point. The points on the frequency versus power curve, where power is half of the maximum power at resonant frequency, are called half maximum power points in the above figure. R and S. At points R and S, P equals to P naught by 2. From equation 3, P naught by 2 equals to P naught R square by R square plus of L omega minus 1 by C omega whole square, R square plus of L omega minus 1 by C omega whole square equals to 2R square. L omega minus 1 by C omega whole square equals to R square. L omega minus 1 by C omega equals to plus or minus R. Multiply the above equation with omega by L on both the sides. Then L omega into omega by L minus omega by L dot C omega equals to plus or minus omega by L R. Omega square minus 1 by LC equals to plus or minus R by L omega. Therefore, omega square minus R by L omega minus 1 by LC equals to 0, or omega square plus R by L omega minus 1 by L omega equals to 0. But omega naught square equals to 1 by LC. Therefore, omega square minus R by L omega minus omega naught square equals to 0, or omega square plus R by L omega minus omega naught square equals to 0. On solving these equations and rejecting their values, omega 1 equals to R by L plus of omega naught square plus R square by 4L square whole power 1 by 2, and omega 2 equals to minus R by 2L plus of omega naught square plus R square by 4L square power 1 by 2. Now, omega 1 minus omega 2 equals to R by L. From the above figure, omega 1 equals to omega naught plus delta omega, and omega 2 equals to omega naught minus delta omega. Therefore, omega naught plus delta omega minus omega naught minus omega delta equals to R by L. 2 delta omega equals to R by L. So we get the frequency interval between half maximum power points. This frequency interval is known as bandwidth. The Ratian resonance frequency and bandwidth is known as quality factor, Q. Q equals to omega naught by 2 delta omega. Q equals to omega naught L by R. Therefore, 2 delta omega equals to R by L. Q equals to 1 by root LC. L by R gives Q equals to 1 by R root L square by LC. Q equals to 1 by R root L by C. In other way, the Q factor or voltage magnification factor of series resonant circuit is the ratio of the potential difference across the inductance or capacitance to the potential difference across the resistance or the applied EMF at resonance. Voltage magnification factor or Q factor equals to EL or EC by ER or E. Q minus factor equals to IXL by IR equals to IXC by IR. Q minus factor equals to L omega naught by R equals to 1 by C omega naught R equals to 1 by root LC L by R. Therefore, omega naught equals to 1 by root LC equals to 1 by R of square root of L square by LC. Q minus factor equals to 1 by R of square root of L by C. This is greater than unity. Q factor is a measure of the sharpness of resonance. Resonance will be sharp if the value of bandwidth 2 delta omega is same. If the resonance is less sharp, not only is the maximum current less, the circuit is close to resonance for a large delta omega of frequencies and turning of the circuit will not be good. So less sharp the resonance, less is the sensitivity of the circuit or vice versa. If Q factor is large, the circuit is more sensitive. 3. Variation of current amplitude with angular frequency. Already we derived that I equals to E by square root of R square plus of L omega minus 1 by C omega whole square. At resonance omega equals to omega naught, L omega equals to 1 by C omega. Therefore, I equals to E by R is peak value of current or maximum current amplitude. The above figure is a graph drawn for angular frequency against current. At resonance, maximum current flows in the circuit. Points R and S represents half maximum power points.